Hello everyone, welcome back to London Code. So in this video, we're going to learn about Amazon VPC, that is Virtual Private Cloud. So let's start with the session. So this is the agenda of this video. First, we'll learn what is Amazon VPC and why we use it. Then we'll learn about region, availability zone, data centers, host, rack, and how they're all related to each other so that we can understand Amazon VPC better. Then some other few key concepts of VPC, that is subnets, gateways, firewalls, IP addressing, and routing. Then we'll go to the demo of how to create VPC in AWS console. So the first question is, what is Amazon VPC and why we use it? As it is written here, Amazon VPC is the networking layer that enables you to launch AWS resources into a virtual network that you have defined. So to understand this, first let's understand how the organizations create the network. So one thing is internet and the other thing is the data center. Internet is the network using which devices from all over the world connect together, right? And they transfer data from one device to the other. Now, data center is the place, is the physical entity where organizations put their IT resources, create the network using LAN, WAN, and connect their devices together, right? Inside the data centers, they put their servers, host, networking devices, databases, so that their applications could run. Now, as I explained in my previous videos, that currently organizations are moving to the cloud technology so that they don't have to build the data centers on their own. Rather, they would go to the cloud service provider like AWS and use their resources. In order to do that, organizations would need a isolated network where they could reside their resources and no one could access those resources unless they allow them, right? For this use case, we have virtual private cloud, which is the VPC, which closely resembles to the traditional network where you would be like operating in your own data center and using the benefit of scalable infrastructure of the AWS, which means that inside that VPC, you can easily spin up an EC2 instance. You can easily use other AWS resources like VPN, VPC peering, and transit gateway, and many more, and without any trouble or without any extra burden. So basically, VPC is nothing but the isolated virtual network, which is exactly similar to your traditional network and with an extra benefit of using the AWS resources easily. So now I hope it is clear what is Amazon VPC. Now, the next question that I believe you would be wondering is how does that work and how is a traditional network becomes virtual and how things work in Amazon VPC, right? So don't worry, we are going to cover everything and I'm going to show you a demo of how to create an Amazon VPC in the console. So let's move to the next point, which is regions, availability zones, and how they combine together and help in the Amazon VPC networking. As we can see here, AWS has the concept of a region, which is a physical location around the world where we cluster the data centers, which means that region is nothing but the physical geographical location, such as Mumbai or North Virginia or Ohio. These are the geographical locations which are present in the world, right? So these are the locations where AWS has created their own data centers, and these locations are called as a region. So if you're selecting a region in the AWS console, this means that you're selecting a particular location to reside your data, and your data will be within that region only, will not go outside of that region. Next is we call each group of logical data centers an AZ, in which AWS has their data centers. Now, AWS has created lots of data centers in these regions. So let me show you the number here. As we can see, AWS has 26 regions all over the world and 84 AZs. 84 AZs means that inside these 26 regions, they have lots of data centers, and those data centers are grouped together. For example, say thousands of data centers. Now, those thousands of data centers are grouped in 84 AZs, which are nothing but a logical grouping of those data centers. Each of the AZ has the independent power, cooling, and physical security and is connected via the redundant ultra low latency networks. Now, all of these AZs are connected together and they have a redundant network, which means if one network fails, they have the other network so that the connection remains intact. Now, to help you understand it better, let me quickly show you a diagram so that you could understand it even better. So in this diagram, as we can see here, this is a region which is a physical location like Mumbai, North America, and then we have the AZ. Now, as we can see here, we have logically grouped these data centers together and made a AZ, and we call that logical grouping an AZ. And inside these data centers, we have the rack and host on which your servers run. And this is how the VPC come into the place. VPC is the isolated virtual network which we have created. When we create a VPC, we select the AZ, we select the region, and then the instances can be launched inside that VPC. And those instances will be in a particular subnet, and that will reside in a specific AZ. All these AZs are connected to each other in a specific region, and the data transferred from one AZ to the other one is encrypted. So we have the complete security. So I hope this is now clear to you. What is a region, what is a AZ, and how they're connected together, and how does VPC come into this place. I wanted to talk to you about Newton School, which is a great platform in terms of learning and developing your skills like full stack development, and they help you prepare for your dream company and without paying any upfront fees, which is great, right? They will help you to build your tech career for the dream companies because they have partnered with 700 plus companies all over the world, and they do not charge anything upfront from you. Their students are already being placed in various companies like Google, Zomato, Nykaa, and many more. So I would highly suggest you to please check out their website and take their courses for free because they're doing a great job in helping students getting good jobs in the industry and building a good tech career in the IT domain. As you can see here, there's zero fee till placement. There's no upfront fees that you have to pay. The students work in top companies like Google, ThoughtWorks, Zomato. They have live classes, industry projects, mock interviews, and personal mentoring that would help you to ace the interviews and get a really good job in the IT industry. So please go check out their website. They also have this amazing full stack web course, which would really help you if you'd like to learn the full stack development. And you don't have to pay any upfront fees for this course. You would only have to pay them after you get your dream company job. So, which is great, right? So, do check out their website. I'll add all the necessary links that are required in the description below. Now let's understand some key concepts of VPC, which is the subnet, gateway, and firewalls, and IP addressing and routing. Obviously, when we are talking about creating a virtual network, we need to be sure about the security policies and security measures, how we are making sure that our data is safe, and how the traffic is routing, and how we are connecting one instance to the other. So for that, let's deep dive into these following key concepts. So this is the official AWS documentation, and these are the following key concepts of Amazon VPC. Let's go through them one by one. First is the virtual private cloud. As I already explained, it is the virtual network which is dedicated to your AWS account that you would create inside your AWS account. Next is the subnet. Now inside that virtual private cloud, you would create a subnet, right? If you understand networking, then we have the concept of subnetting, where we divide our network into multiple subnets so that we can have your resources inside within those subnets, right, for routing purpose. Next is CIDR block. CIDR block is nothing but the IP range of your network that we allocate to our VPC and subnets. Next is the route table. Route table is the set of rules called the routes, which are used to route the traffic from one instance to the other, or to go to the internet, how traffic routing should work in your VPC. Next is DHCP option set. As we all know, DHCP is the dynamic host configuration protocol, which is used to configure your domain name and the domain name server so that you can assign that information to the EC2 instance instances which you would launch in your VPC subnets. Next is the internet gateway. Internet gateway is the gateway which you would attach to your VPC so that you can enable communication between the resources in your VPC, like EC2 instance, and the internet, which means that if you want to connect your EC2 instance to the outside world, to the internet, then you would need to attach the internet gateway for public access. Next is egress only internet gateway. This is the similar way that internet gateway works. It is a type of internet gateway that allows an EC2 instance in a subnet to access the internet but prevents resources on the internet from initiating communication with the instance. So in the internet gateway and the egress only internet gateway, the difference is in internet gateway, you can reach to the internet and someone from the internet can also reach to the EC2 instance or the resources inside your VPC. Next is NAT gateway. NAT gateway is the managed AWS service which helps your EC2 instances in private subnet to connect to the internet. Next is the NAT gateway. So if you have an instance inside a private subnet and you want your EC2 instance to connect to the internet or the on-premises, then you can use NAT gateway to enable. Next is NAT instance. NAT instance is similar to NAT gateway. The main difference is that NAT instance is similar to NAT gateway in terms of functionality. The main difference that NAT gateway is a fully managed AWS service. Now, the main two things that I wanted to mainly focus on is the security group and network ACL. Security group is the virtual firewall to control the inbound and outbound traffic for an AWS resource, such as EC2 instance. Each VPC comes with a default security group and you can create additional security groups. A security group can be used only in the VPC for which it is created. Now, security group is just like a firewall that is attached to your VPC, and network ACL is the optional layer of security for your VPC that act as a firewall for controlling traffic in and out of your subnet. Both of them are very important in terms of security purpose, and they both act as a firewall at different layers, because using the security group and network ACL, you can control the traffic which can come inside your VPC or which can come out, which can go outside your VPC. So you would have the control over that. For example, if you want to block a specific IP range or you want to allow a specific IP range to access your EC2 instances, you can allow them or block them in the network ACL. So when you create your VPC, you should make sure that security group, NACL, and the route table are configured correctly in order to secure the resources inside your VPC. So these were the main key concepts of VPC. Now let's see demo of how to create VPC. So let's start with it. So now I am inside my AWS console, and you should see a similar screen on your end as well. On the top right corner, you can see the region that I'm in. Currently, I'm in the North Virginia region. If I click here, I can change it to North California. I can change it to Ohio. And then if I have to create a VPC, I would type here VPC. And as you can see in the services, it came. So this is the VPC console. Let's go through the VPC console and see how to navigate through this console. This is the left pane where you can find the subnet, route table, internet gateway, and many other services. This is a very nice overview how many number of resources you have inside this region. For example, the number of VPCs, net gateways, peering connections, NACL, security group, and many more. Then here it is the service health. So service health is the place which will tell you current status of resources in this region. Currently, we are in Ohio, which is US East, and we can see that the current status of EC2 service is normal. If I click here, view complete service health details, it will land into this page, which is the official service health dashboard of AWS. And you can check and confirm if the services are working fine or not. And whenever an outage happens, then this is the official health check dashboard that you should go to. And you can check if there's an outage in a particular AZ or in a region. Next is the settings. If you go to the settings tab, you can check the zones. Here you can check the availability zones for your region. Under additional information, you can find links for documentations, resources. Then these are some additional links that they have provided here for easier use. You can find them under the left pane also. So this was the overview of VPC dashboard. Now let's start with how to create a VPC. So there are various ways using which you can create a VPC. One is using the launch VPC wizard, which is this option, and the other one is you can click on your VPC here, or you can click VPCs. You will land into this page, your VPC page, where all the VPCs you can see inside this region, and you can click on create VPC. Now before creating this VPC, I wanted to mention one thing, that if you go to any region, you would find that there is a default VPC that you can see here. I didn't create this VPC, but it is still listed here, right? And if I go to any other region, I would find one VPC listed there, and which I didn't. So who created this VPC? And just to clarify, there's no cost associated with the VPC. Only the resources that you would create inside this will incur cost. You can also log into your own console, and you can see that there's a VPC listed, and in every region that you would go. So let me tell you, it is actually a default VPC that is created by AWS. You can see the default VPC option is yes. This is a default VPC that AWS creates in every region for easier use. Benefit of having these default VPCs in every region is that you don't have to think about creating a separate VPC. You can just launch your instances. For example, if I am just looking for launching an EC2 instance in this region, I don't have to think about first creating a VPC, then attaching a internet gateway, then creating NACL and root table, and all of these parts that are required while creating that VPC. So instead, all of those extra steps just to launch a EC2 instance, AWS provided us very easy to use option, that is they already created a default VPC where you can just go to your EC2 instance and launch that instance without worrying about, oh, I want to create a VPC and all the other details and configurations, right? So this is useful. But for this demo purpose, I'll show you how to create a non-default VPC. Let's see the launch wizard option. So it has 4 options available for you. In this wizard, it will create a CIDR block of /16, which is the maximum that you can use, and a subnet of /24, which means you would have 256 IPs inside that, and you can associate those IPs to the EC2 instances. Next is this option will create a public and a private subnet. So basically, this is the diagram. As you can see, private subnet instances will access the internet via the public subnet and this NAT device. There will be no inbound traffic coming from internet to the private subnet. The next option is VPC with public and private subnets and hardware VPN access. In this case, again, you would have a /16 network. That is your VPC, and inside that you would have 2/24 subnets. That means 256 IP range in both the subnets, and one subnet is directly connected to the internet, while the other subnet is connected to your corporate network via IPsec VPN. Now, VPN is another AWS network service, and we would cover it in a different session. It is a very useful and very important service to use. Next option is VPC with a private subnet only and hardware VPN access, which means here you would only have a private subnet, and it is connected with your corporate data center, which is the on-prem, via the IPsec VPN. Again, you have all these options available, which you can use easily and create your VPC. I'll go with the first option, and please note that in all these options, we are creating resources such as VPN and NAT gateway or NAT instances and EIPs. All of these resources have a cost associated with them. So please make sure once you're done with the demo, or once you're done using them, please delete those resources. Otherwise, you would incur cost. So let's start with the first option. I would be creating this architecture, meaning we will be creating a VPC /16 CIDR. Inside that, there will be a subnet with /24 CIDR. So let's go select. Now, as you can see, this is a CIDR range that it will be using. Then this is the subnet range that we will be using. Now here, one thing to note is 251 IP addresses available. You should be wondering that why there's 251. Ideally, it should be 256, right? This is very important to note that AWS reserves 5 IP addresses in each subnet that you would create for routing purpose. Let me show you official documentation. See, the first 4 IP addresses and the last IP address in each subnet CIDR block are not available for you to use and cannot be assigned to an instance. Following 5 IP addresses are reserved. So these 5 IP addresses are already reserved that you cannot use and you cannot assign to any instance inside that subnet. So that is why there was only 251 IP addresses. Okay, so I hope this is clear now that why we are seeing 251 IP address available. There are many other options also. For example, CIDR block, you can choose if you want to have IPv6 CIDR block, or maybe Amazon provided IPv6 CIDR block. Then you can enter your VPC name as well. I'll mention demo VPC. You have the option of choosing the availability zone. As I mentioned, all the VPC, any VPC you would create, it will be spread across the multiple AZs for high availability. So I'll choose US West 2A. Public subnet name, you can name it. I'll name demo subnet. Okay, once this VPC is created, I can also create more subnets inside this VPC. Click on create VPC and it will be done in few minutes. I got the message that my VPC has been successfully created. You can launch instances into the subnets of your VPC. This is my demo VPC, as you can see. And the details, as you can see, the default VPC is no, which means that this is not a default VPC created by AWS. CIDR block is this, and root table and main NACL that has been associated with this VPC, we can see that. So if we go to the routes, there's only one route currently present in this route table, which means that only the local communication can happen inside the VPC. So for public access, we would have to attach the internet gateway, edit the routes, and attach the IGW, which is the internet gateway. And as you can see, so this, when we created a wizard, it already created a IGW. So now we just have to associate it. So now, since we have internet gateway associated, we can see the status is active and the routing should work. So we have our VPC in place. Let me show you the subnets. We created a demo subnet, which is this. All the rest of the subnets are for the default VPC. We can see here that the default subnet is yes, and for our VPC, for our subnet that we created, it is no. You can see the AZs associated and the available IPv4 addresses that are available. You can check the subnet details here in the root table. As I showed you, there are two rules. NACL, all the traffic is allowed. So we are good with the VPC part. Let me quickly spin up an EC2 instance inside this VPC. So I created a test EC2 instance, and as you can see the details here, this is the public IP address and this is the public DNS for this EC2 instance, and the VPC ID is this, and subnet, demo subnet. Inside the demo subnet, for security, this is the security group that I created, and I've given the two rules. I have given SSH access and ICMP access. So I want to SSH into this EC2 instance, and from that EC2 instance, I want to access Google, which would confirm the public access. Under networking, you can check all the networking details of this EC2 instance and the ENIs. ENI is the network interface which is associated with which actually the security group is associated and controls the traffic routing from in and out of this EC2 instance. So let me quickly show you by SSH into the EC2 instance. Click connect. So to SSH into this EC2 instance, there are various options. I'll go with SSH client, and this is the command that I'll copy and I'll run in my terminal. Doing SSH into the instance is quite easy. First, I would suggest you to change the permissions of the PEM file that you downloaded. This is the private key of your instance that you use to SSH into the instance. So make sure that you are making this file secure by updating the file permissions, and then you just have to run the command that you copied, SSH-i. This is the private key that you downloaded. Then your username of the instance and the DNS. If you want to connect, then type yes, and you should be able to SSH into the instance easily. Now, as I showed you that I have enabled ICMP traffic in my security group and I have IGW associated with my VPC, which means that I should be able to access the internet and I should be able to ping the www.google.com from my EC2 instance, right? So let me quickly see ping www.google.com and it should work. And there you go. You can see that I'm able to ping google.com, which clearly shows that I'm able to access the internet and the networking is working fine. So that's all that I wanted to show you in this video. I hope it was helpful. See you in the next video where we will cover more such topics and hands-on practice on the AWS services. So thank you.